Hello and welcome back to Elementary Algebra. I am Amy Flicksteiner, your instructor. We are working on Chapter 3, Section 2 today. We're going to look at whether or not an ordered pair is a solution to a linear equation. We're going to complete some ordered pair solutions, construct tables, and use that table to graph the equation by plotting the points. And then we're going to graph the equation using some variables other than x and y, just to quite simply prove that it doesn't have to be an x and a y. So a linear equation is an equation in two variables, generally of the form y equals some number times x plus another number, or sometimes in the form ax plus by is equal to c. In both cases, you will find a y and an x in the equation. Whoops, not the b, the y. There we go. An x and a y in the equation, where m and b and a and b and c are all just meant to be some rando number. Okay? Solutions are ordered pairs that satisfy the equations. That is when you replace the x and y with the values of the ordered pair, a, b, those numerical values check the equation. For example, is negative 5, 4 a solution to y is equal to x minus 1? To determine this, we have to recognize that negative 5 is in the place of the x coordinate and negative 4 is in the place of the y coordinate. Then we simply do the substitution into the equation. Y, we're going to put in a negative 4, is that the negative 5 minus 1. To reiterate, this would be negative 4. This would be a negative 5. So is negative 4 equal to negative 5 minus 1 more, or negative 6? That is clearly a no. Since the equation does not work with the values given by the ordered pair, we know that this ordered pair is not a solution of the equation. Does 9, 8 satisfy y is equal to x minus 1? Again, this 9 would be our x value and 8 would be the y value. So 9 minus 1. The y goes in as 8. The x is here. Is 8 equal to 9 minus 1? Well, 8 is equal to 8. So that is true. What does that tell us? That tells us that 9, 8 is on the line. Whoops. Forgot my e. Y is equal to x minus 1. So if a point satisfies an equation, then it is on that line. It is a point that we can graph. Negative 2, 5. This would be our x value. 5 would be the y value. Y is equal to, and x squared minus 1. So our y value is 5. Our x is a negative 2. So we would have 5 is equal to a negative 2 squared. That's negative 2 times a negative 2, or a positive 4 minus 1. Here we have 5 is equal to 3. So this is clearly a no, because it is not a solution. That would tell us that that point is not on the line. There we go. Let's move that a little bit. There we are. Does 0, negative 4 satisfy the equation y is equal to 3x plus 4? Y is equal to 3 times the x value plus the 4. In this case, our y value is negative 4. Our x value is 0. This would stay a negative 4. 3 times 0 is 0 plus 4. Is negative 4 equal to 4? This is not true. So this is also a no. That point is not on the line. We can use this information to determine the correct solution or the ordered pair that would be on the line. So if we have to complete the solution, some number, comma 8, for the equation y is equal to 2x minus 3. This is our x value, which is not known to us. That's why it's blank. And 8 is our y value. So we would have, right? Our y value is this 8. Our x value we did not know, so I'm going to put an x in there. This gives us 8 is 2x's minus 3. So in order to determine what our x value would be, we can use our good skills about solving equations here to add 3 to both sides to get 11 is 2x, and then divide both sides by 2. So if we want our y value to be 8, as is stated here, our x value has to be 11 over 2. This tells us the correct ordered pair that would be a solution to y is equal to 2x minus 3. Okay. The next one says to complete the solution, negative 6 comma something. So this is our x value and this is our y value. For the equation y is equal to 2 times our x value minus our 3. Now we know the x value here is a negative 6. The y value we don't know, so I'm just going to put a y in there. When I simplify this, I have y is a negative 12 minus 3 more. To solve this, there's no solving. I just need to put it together. Y would be a negative 15. So our solution here would be a negative 6, negative 15. This would be the ordered pair that serves as a solution to y is equal to 2x minus 3. All right. We're going to build on that to construct a table of values. With that table of values, we're then going to graph the equations by plotting those points. Here's the idea. We're going to input several values, up to 5. We're going to input that value of x. So we're going to pick 5 x values. And then we're going to put them into our equation to determine what y would be. Now, best case here is we start with a negative number such as negative 2. We work on negative 1, then 0, 1, and 2. These are the 5 most commonly used in the table. So what are we going to do? We're going to first do y is equal to 2 times a negative 2 minus 3. That's our work. 2 times a negative 2 is negative 4. Minus 3 more is negative 7. This gives us our first point at a negative 2, negative 7. We'll do that for a negative 1. In this case, y is equal to 2 times a negative 1 minus 3. That's a negative 2 minus 3 more. That's minus 5. This gives us a second point at our x value at negative 1 and our y value at negative 5. Here's the thing. We're picking those x values. They're not being told or given to us from anywhere. I am literally picking them out of thin air, right? Don't think that this is something that, I don't know where those x's came from. You don't know where those x's came from. We made them up. I got to pick them. And so I'm picking negative 2, negative 1, 0, 1, and 2. Could I have picked a 73? Absolutely. But that would not have been a point that I could plot on this graph. X equal to 73 would put it way out over here. And I don't want to have to graph that. I want to be able to graph easy numbers to just get a feel for where the line is. Simple numbers, right? All right. Like 0. 0 is one of the simplest and best numbers you can pick, because when I put 0 in for that x value, 2 times 0 is 0. Minus 3 gives me a negative 3. So this puts my point xy at 0, comma, negative 3. Then I'll do a 1. 2 times 1 minus 3. 2 minus 3 is negative 1. And I'll do my 2. 2 times 2 minus 3 is 4 minus 3, which is 1. This gives me 5 points to plot. And plotting each one of these points, I'm looking only at the xy here now, will graph the line for me. So I've got a negative, here's my, starting at 0, 0. I'm going to go back 2, down 7. 1, 2, 3, 4, 5, 6, 7. There's my first point. My second point says back 1, down 5. Then 0, negative 3. So I'm not going to move left or right. I'm just going to go down 3. Then I have 1, negative 1. And I have 2, 1. And with these 5 points, I have a line. Using some straight edge, I'm going to go ahead. And using that straight edge, I'm going to connect those points together. This gives me the line that represents y is equal to 2x minus 3. All of the points that work on this line are solutions to the equation. And even though I did not find them, I can use my green marker to indicate what other points should work, like the point 3, 3. So 3, 3, even though I didn't check it, should work on this line. So 2 times 3 is 6. 6 minus 3 is 3. Yep, that would get me 3, 3. Even the points that aren't pretty will work on this line. What do I mean by that? Well, what if I went 1, 2, 3, 4, 5, 6 and a half, and then I went up? If I go 6 and a half and then I go up and meet that line, I'm at the point 6 and a half. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 6 and a half, 10 should be a solution to this equation, even though, whoops, here we are. Boop. Even though I did not necessarily check that, I know that that should be a solution to the equation. Oh, this is being trouble. Trouble right here in River City. There we go. Okay. Here we have a second table with a fraction. What do we do when a table has a fraction? Remember I said you get to pick your x values. I want x values that will cancel with the 3 in the denominator. So I'm going to choose a negative 6, a negative 3, a 0, a 3, and a 6. I'm going to go ahead and choose multiples of that 3, both positive and negative, and because it's a great number, 0. Then I will have y is equal to 1/3 of a negative 6 plus 4. 1/3 of negative 6 is negative 2. Negative 2 plus 4 is 2. Then I have y is 1/3 of a negative 3 plus 4. 1/3 of negative 3 is negative 1 plus 4 is 3. Negative 3, 3. If I put in a 0, 1/3 of 0 is 0 plus 4 is 4. Whoops, 0, comma 4. 1/3 of 3 is 1 plus 4 is 5. 3, 5 is my next point. 1/3 of 6 is 2 plus 4 is 6. And now I want to plot these points. So starting at the origin, where my x and y axis intersect, I'm going to go to the point -6, +2, -3, +3, 0, 4, 3, 5, and 6, 6. Once I have those points, I will take a straight edge and graph it. There we go. There is the equation of the line. Now, all of the solutions to this equation are represented by this line, even if they are points that I did not find. So what does that mean? That means that this point right here, which is like a -2, and then up 1, 2, 3 and a third. I'm guessing it's close to 3 and a third. That this point, -2, 3 and a third, will be a solution to this equation. It will work in that equation. Okay. Okay. How are we doing? Do we need to do 2 more? Why not? You can always just fast forward. Okay, so here I have another table. I have an xy value. I have y is equal to x squared plus 2. I don't have any fractions here, so I'm going to go ahead and choose -2, -1, 0, 1, and 2. Again, without the fractions, I can leave this uncomplicated and just choose -2, -1, always with a 0, 1, and 2. Hitting negatives, 0, and a positive. That's always our big ideas here. So then when I substitute them in, y will equal a -2 squared plus 2. -2 squared is -2 times -2. That's a +4. Plus 2 more is 6. Y would equal a -1 squared plus 2. -1 squared is a -1 times a -1. Negative times a negative is a +1. Plus 2 is 3. -2, 6. -1, 3. Y is equal to 0 squared plus 2. That's just going to be 2. Y is equal to 1 squared plus 2. That's 1 times 1, which is 1, plus 2, which is 3. And then we have y is equal to 2 squared plus 2. 2 times 2 is 4, plus 2 is 6, giving us the point 2, 6. Now, let's see. -2, 6, 2, 4, 6. -1, 3. Then I have 0, 2, 1, 3, 2, 6. All right. This does not make a line. This graph is something different. It's a different shape than a straight line. It's actually called a parabola. And it's one of the reasons that we do 5 points. Because in order to catch the shape of it, we need to do more than just 3 points. Right? I know this is a parabola because I have had lots of practice and because this is squared. The fourth example uses the absolute value. There are no fractions here, so I'm going to go ahead and keep it simple with the -2, -1, 0, 1, 2. Because I don't have any denominators I need to eliminate. Then my y value would be the absolute value of a -2 minus 3. The absolute value of a -2 is 2. 2 minus 3 is -1, giving us the point -2, -1. Then y would be the absolute value of -1 absolute value, minus 3. The absolute value of a negative 1 is 1. 1 minus 3 is negative 2, giving us a point at negative 1, negative 2. If we let our x value equal 0, the absolute value of 0 is 0, and when I take 3 away, I will be at negative 3. So 0, negative 3. If I let my x value equal 1, the absolute value of 1 is 1, minus 3 is negative 2. And for 2, the absolute value of 2 is 2, minus 3 will be a negative 1, giving me the point 2, negative 1. Now, when I graph these, I will get a slightly different graph from the ones before. Negative 2, negative 1, negative 1, negative 2, 0, negative 3, 1, negative 2, and 2, negative 1. These 5 points form an actual V with a sharp point there. This is an equation of an absolute value. And the graph of an absolute value will always look like a V. It moves around a little bit, but the absolute value equation always looks like a V. Like absolute value. That's how my brain worked. Absolute value with the V shape, right? This gives you a good idea of several different tables and the graphs that they give you, right? We're going to have you look at when you do these. Most of what we're going to be doing in this particular unit is going to be like the first two here, with the y is equal to 2x minus 3 and the y is equal to 1/2 x plus 4. But you may also get some parabolas, which look like u's, and absolute values, which look like v's. Okay, just so you are aware. Now, the last part of this section asks you to graph equations in variables other than x and y. You're not going to be any different. We're just going to put in a different letter. So here we have a graph that shows the relationship between the distance d traveled by a softball and the height h that it reaches. Based on the graph, what does the following point 40, 40 give us? If you look at it, 40, 40 basically tells us that at a distance of 40 feet, the height of the softball is also 50. It was also 40, sorry. Okay, so it's basically just giving us the distance and the height, only instead of x, we're calling it d, and instead of y, we're calling it h. No big deal. At what distance from the plate does the softball reach its max height? So the max height is right about here. And it appears that the distance has to be 100 for the height to be 60. So the distance from the plate is 100 for the height to be 60. At what distance from the plate? That's 100 feet. Where will the ball land? If you assume this is the starting point of the ball and that it travels up, where does the ball land? 200 feet away. Okay, 200 feet away. Here, we're just not using an x and a y. We're using a d and an h. No difference other than that. All right, second example. Complete the graph of the table and graph the resulting points. So here we have the length of a bolt. We're calling it L. And the cost to manufacture that bolt in cents, capital C for cost, can be described using the relationship the cost is equal to 2 plus 1/2 L, or 2 cents plus 1/2 the length. Okay? Notice this would be like our y, this would be like our x. Since the L's are what we're starting with, and that is being multiplied by a fraction, I am going to start with multiples of 2. I'm going to start with a -4, a -2, a 0, a 2, and a 4. Again, I'm choosing multiples of 2 because 2 is my denominator. That means that for the first one, the cost would be 2 plus 1/2 of -4. Half of -4 is -2, so this cost would be 0. This gives us -4, 0. Here the cost would be 2 plus 1/2 of -2. Half of -2 is -1, plus 1, or plus 2 is 1. If there's no additional length, the cost would be 2 plus 1/2 of 0. That's just going to be 2. That makes sense. If the extra length is 2, then I have 2 plus half of 2, which is 1. So that's going to be 3. 2 is 3. And if I have an extra length of 4, the cost is going to be 2 plus half of 4, which is 2. So that's 4. 4, 4. Okay. Plotting this, I'm just going to plot the points. -4, 0. -2, 1. 0 is at 2. 2 is at 3. 4 is at 4. And this gives me the graph of this line. Now, here's the point. Here's where we need to put on some critical thinking. Can we have the length of the bolt in the negatives? I can use it to plot the graph. That's not a problem. But in reality, I cannot build a negative bolt. I cannot build a bolt that has a negative measurement. So when we look at this graph, the part that's going to matter to us is just going to be everything in this first quadrant. This part here is not necessary to us because it's negative. We can't have negative values for the length. We could maybe have negative values for the cost, but not using this equation, okay? All right, so using this, we could maybe approximate 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So what if we had, let's say, 10 units of extra length? Now, because I've drawn in the graph, I can figure out that if I have 10 extra units of length, the cost of this bolt, 2, 3, 4, 5, 6, 7, is going to be 7 cents. So each bolt is going to cost 7 cents if I have 10 extra units of length. All right. So do you feel that we have sufficiently met the goals for you? Are you able to determine whether or not an ordered pair is a solution? Can you complete an ordered pair solution if given an equation? And can you construct the table of solutions and graph it? And how do you feel about switching out the variables for x and y? If you have questions about any of these goals, please do not hesitate to contact me or drop into the Math Center to get things solidified for you. All right? Thank you.